Welcome to the Brainstorm with Sparks and Finn, a podcast where we brainstorm the science and philosophy of a new age, an electric universe age, and what it means for the human race, past, present, and future. I'm Finn, author, narrator, and Euro opera metal fanboy who just found myself on a Zoom call with the keyboard guy from Nightwish.
And I'm Sparks, physicist, experimentalist, and I have no idea what the hell Finn's talking about in this. A Nightwish to me is either some rumpy-pumpy or a bathroom visit.
Wait a second, Sparks, that's not Thomas. Welcome, ladies and gentlemen, the great
Stefan
Amala, a mad scientist with his head in the clouds. Lucky for us, he figured out how they work while he was up there. So buckle up, cause you've got some learning to do.
Hooray!
Yeah, that wasn't that difficult.
No.
I'm soon a nerd. Like, I spent 2 minutes with you and I transformed into a nerd.
I love the background you picked too. That's awesome. That is so appropriate.
Yeah, it's very cool.
Yeah, I had to laugh because I was trying to set the whole thing up and then I was just going through all the settings. And then there were like about these artificial backgrounds, so to say. And I just noticed that there's like auroras and they're even moving. So I thought that's pretty cool.
That is really cool.
How did they know that I would like to use this?
It's very
It's
poignant. You look like a wizard.
Yeah. Yeah, man,
Nordic wizard.
a witch. Yeah. Like I have been.
Yeah, let's Matt and Stefan. We haven't made any introductions. I've talked to Stefan a few times, and I met him because I found out that one of his videos that he produced had a clip of my video in it. So I reached out to him and said, "Hi, who are you? What are you doing?" And found his stuff, and we've been talking ever since. But Matt, do you have any questions for him before we get going?
Well, yeah. What do you do? What is your environment of science?
It's basically everything. You know, it's not
Natural philosopher.
Yeah, like I stumble across so many things all the time, and somehow, like after discovering the electric universe and things like that, it was all of a sudden so easy to find analogies between things, how things work. So after all, like Andrew Hall once said that studying geology is studying petrified weather. And this was very intriguing. And I will show you in my little presentation a few examples of exactly this thing. So it's very interesting not only to watch the clouds, but you find the same patterns in the rocks or landscapes. And yeah, like we all have our lives to live where stuff is happening. So you're getting confronted with challenges and stuff like this. And this also brought me to, in a way, a broader perspective about the transmutation of elements, because I'm pretty sure there are many more elements than just those we have on the famous table of the elements, because we have the elements of feelings, the elements of seeing, the elements of thoughts, and all these kinds of things, which are not really, you cannot picture them, because you cannot take an image of your feelings and show it to someone and explain, yeah, this part of the picture represents this and all these kind of things. So they are just how to put it.
Maybe.
Eileen McCusick might be able to by transferring it into sound and then having it appear in
Right.
Yeah, that's the thing. That's about basically, yeah.
There is something tangible there, but how to capture it?
Well,
the thing is, if we like what you said in the beginning, I look like what did you
a wizard?
Wizard? Yeah,
a wizard.
Yeah, but it seems somehow like the evidence suggests that I seem to be a witch. Like the thing is, like in Finnish language, the word science is derived from the ancient word witch. And another word for witch is also knower. So apparently, since
She's a witch.
I've managed to even get some papers published, like peer-reviewed science. So that's further proof or evidence of being a knower, so to say, because I have those papers and stuff. And there would be many other things about what it means to be a witch and like this. Like, if you know Terry Pratchett, I really recommend you to read the Tiffany books and stuff. There he talks about witches, and it's very interesting. I didn't knew about that before, and the thing is also about alchemy. Not only the word is very often not fully understood because the beginning, the first two letters, al, is for the entity itself, like Allah or Elohim.
Right. It's
or
pointing to the person.
Like, yeah, it's about the carrier of the spiritual entity, basically the human, the dude. Okay.
Sure.
Like if there's a holy, like someone gets like to a status of being a prophet or whatever, he probably gets somehow a title, or it's like it points to a certain entity, the beginning of the word alchemy. And chem is the old word for Egypt, as we have learned. So the thing is, at one point in history of science, they took off the L from chem. So we just have the word chem left. In other words, nowadays, modern scientists, like not all of them, but I assume that probably all of them to some degree, they became scientists because they wanted to know. Okay? But then after a while, they figured out they got squeezed into a certain kind of thinking. You have to specialize onto certain things. And after you have specialized on several things, maybe after that, you get the possibility to try to get a picture of the whole thing. Yeah, so maybe it's not the right approach in order to figure stuff out. You have to look at the whole thing all the time. Like you cannot
the Gestalt view.
You cannot, like, if you hear something which is new and maybe thought-provoking, or like you don't agree, but first you have to understand that you have to understand the other theory. What's the basic idea of whatever new stuff you stumble across? And only after you understood the basic idea of the new theory, then you have the ability to compare to what you already know.
Compare and contrast. Yep.
And
exactly.
If it does it resonate? Do you find similar patterns to what you think on the whole thing? So, in other words, about the chem and alchemy, many, or like it seems to be like scientists, they go to work, and after work they are just living normal lives, and next day when they go to work, they're again scientists for the time being until the working day ends. So they may not really get a spiritual experience while being at work, because if they really could make their own investigation into the things that they were originally interested in stuff and wouldn't have to fulfill certain timetables about being worried about the funding of their work in order for them to have some bread to eat and stuff like this, then they could probably find stuff and get their minds blown. And after you get your mind blown for the first time, you're there just, whoa, something happened. I see things different. So it's an actual experience. You know, it's not just only, it's the aha experience. You're there, whoa, dude, that's every time you get this kind of an experience, you will transform as a human. You cannot basically go back anymore. So that's the path further. And you're brightening up. So it's the enlightenment, basically, which is missing in modern somehow science, because they are just clinging on to whatever paradigms they have, searching for black holes and figure out.
Nobody understands it.
Yeah, they're just figuring out theories
They're
after
making up
theories.
stories.
Yeah. And
nobody understands the whole, so they just.
And no one ever found one.
Yeah.
They're just
Well,
anime.
they say they have.
Yeah. An
that's
artist's
different.
impression or depiction of a black hole. Yeah, that's all you got, really?
Yeah,
It looks
exactly.
strangely like a plasmoid.
Exactly, looks like a plasmoid. Hey, Stefan, before we get going too much, because there's a lot of things that I want to ask you about, especially clouds. Got some really good questions for you. Let's let everybody know a couple things. Tell everybody where you're at on the planet, and I'll start helping with this. It's 11:06 a.m. where I'm at. Matt, what time is it where you're at?
It's about 8 o'clock in the evening.
8 o'clock in the evening. Where are you at?
Yeah, I'm in Eastern Finland. Which, How
cool is this that we can have this conversation worldwide? That's just awesome.
Yeah,
modern technology.
Yeah, where are you at, Matt?
I am in Seattle, Washington.
Oh, okay. All right.
Fortunately, outside of it, but yeah.
yeah, that's a nice place. Music place.
Good for music, good for backpacking.
Yeah.
Well, Matt, Stefan was, I don't know if you remember, but Stefan actually presented at the salon that I put on last year. And I invited him to come back and do that same presentation. And that's what he's going to do. So he'll do that first, and then you and I will get a go and have some interaction with him.
I'm very excited for it. I haven't seen it, so this is all new to me. I did want to say one thing, though, about the alchemical, al being the prefix. That's funny because in Sumerian it's the same thing, but it's El.
Yeah. It's al or el.
Yeah.
But that's the thing about education. Yeah, it's in my presentation, and no one has ever seen. Like, I made a new presentation because it would probably be boring to show the same thing again. There might be some same pictures, I don't know. But anyway, the thing is, in modern society, not only leave they things out, they don't tell people certain universal rules. Like, if they would teach in school about the right-hand rule, like if you can make it in kindergarten, kids will understand because they can just look at the hand. It's always with them. If you don't remember, just look at the hand. And it's very simple. And it's so fundamental. If you once really take, like, how to put it, like if you really once understand the significance of the right-hand rule, it's very mind-opening, because all of a sudden you can recognize these patterns all over the place. And it's so fundamental. And it's only electricity and magnetism, electromagnetism, that does this. So
I think it's a way for it to move through energy or through a medium. Yeah, it kind of filaments. It's like a corkscrew.
Basically, in a way, maybe we should have two thumbs, because Birkeland currents tend to be in pairs. So that's a little. Two thumbs on one hand.
Well, Stefan, speaking of stuff that's not being taught, and you also use Seeing the Pattern, Gareth Samuel's latest Seeing the Pattern video talks about a rule that got forgotten.
I saw that. Yeah.
And I
saw that.
You saw it, didn't you?
It's so good.
Holy crap. How did we not know this?
And then on a couple episodes before, he talked about how we change the rules of plasma as soon as we get into space. We completely simplify them. But plasma acts exactly the same no matter where we see it, even in a vacuum chamber. But somehow, once it's in space, it stops doing anything. What a bunch of nonsense.
It is.
So, where is the Earth at? Yeah, I think we are in space. So, you know,
where is the Earth at?
It's not that. Yeah, it's and after, if you understand this, that the next question is, so, like, where does space stop? Yeah, probably it doesn't stop anywhere. It goes through it. Earth, we are the space, a part of it. We are not separated from it. we are a part of the space.
Exactly.
You know,
Yeah.
there's no. It's at the fractal nature of nature. So like circuitry and all this kind of stuff. It's just like from the smallest part to the biggest. It just repeats, and it depends on.
And it's layered. And it's layered. So if you want to say the layers are the separation of space, I guess you could say that. But, you know, when you go like this, when you move your hand up through it or ascend through a balloon, you're not feeling yourself going through layers. The layers are just arbitrary distinctions that we have found a characteristic at and said, therefore, there's a layer. But, Stefan, you're absolutely right. We're in space. And I just did some experiments in my lab that Matt knows about that clearly demonstrate that this right here, all the stuff around us, is dark mode plasma. Unequivocally. But if you look it up online, there's so many answers of what dark mode plasma is and where it is. But Stefan, you're right. It's not out there. It's here. This is it.
Yeah, like what's the origin of the word plasma in the first place? I don't remember who. It was this one guy who was he was making research about blood, I think, and he figured that it behaved strangely, and he gave it to the blood first, like blood plasma. And basically, the first time this word got used, it was used in human blood, in the context of human blood. So afterwards,
because it was so complex and lifelike.
Yeah, and now, like in my background, we have this aurora. And yeah, it's plasma, it's clear for everybody. So, yeah, the origin of the word plasma is like basically our blood, which is very interesting. Now it's just only out there in space somewhere, really? No.
Bloody space.
Like if we have, like, the origin of the word plasma is in with ourselves. And now somehow this connection got forgotten. Now it's just only out there in space somewhere. No, like, you know, if the origin of the word is in with ourselves, it cannot go too far from us.
Yeah.
Right.
So maybe
I think people are figuring it out.
Yeah, maybe with some Googling, we'll figure out who invented the word plasma.
Google. Have anything else to ask him? Let's just have Stefan start with this presentation. You okay with that?
Yeah, I'd love to hear it.
Okay, so here we sit. And this is where Matt puts in fun little animations.
Hey, what? I'll have to find it later.
This is where Professor Dave pops his head in and screams. There we go.
I'm going to get sued.
All right. Now,
what have we here? Critical thinking is something the obvious.
Recognizing the obvious.
All right. Damn straight.
Simplicity and similarity. Maybe I have to put you here on the side. Simplicity and similarity. Sun, sulfur, clouds, and the plasma rocks. There might be some other themes as well, but let's just go into this. Critical thinking is recognizing the obvious. Andrew Hall.
Of course, it was Andy. That's a brilliant quote.
Yeah. Education without enlightenment is dangerous. Manly P. Hall. So I decided to use two Hall. What is it?
One of them is
named. Yeah. I really recommend you to listen to Manly P. Hall. It's very enlightening. So we are the people of the sun. Speaking of enlightenment and light, I made this picture of the sun like on 30th of May this year, I guess. Yeah, we have still 2025. And you can really see the sun. And it's this one.
Robert Hawthorne would love to see that.
Yeah, he would.
And here in Finnish, in English language, we have the sun. Okay, that's nice. The sun is, of course, in English, it's the sun, but in Finnish, it's aurinko. And somehow I found, because the first three letters seem to have some ancient roots, maybe.
Aura.
And the chemical shortening is AU, which is aurinko. Okay, aureatus, decorated with gold. All right, that's very interesting.
That is.
From aureus, golden, aurum, gold. So, and also we have mentioned brass, copper, and bronze. That's also interesting. I don't think I dive too deep into the gold and copper thing now. But anyway, the sun has some interesting activity every now and then. That's from the year 2021. And we have some discharge events here. And here's another one.
Holy
Yeah, it
moly.
looks like lightning. And these are like...
Is it a plasma filament, or do we know what it is?
I don't know. I haven't seen anyone ever talking about this particular thing. And since it's a few years old, there's maybe after this presentation, there's some talk.
Because I agree with Matt. It does look like lightning. Absolutely.
Yeah. And then it's also interesting, like, hopefully you are aware of how corrupt this data sometimes is. I have some examples of how they reuse certain frames and data and stuff like this. So this somehow looks interestingly similar to this one, despite it's on the next day or something, many hours apart at least. And here we don't really see what's the date, but here we have some black dots. And I even have some little clips on my channel that carries the name Sun Machines, because at this very spot where this, let's say, lightning strike emanates, we have the Sun Machine activity. But that's another theme. I just call them Sun Machine because sometimes they really look like machines.
I agree.
So, is the composition of CME an underrated factor? What has sulfur to do with all that, if anything? Yeah, that was a really interesting time-lapse video because all of a sudden the sky turned red. And here we look at some real-time solar wind observations. We have the BC and the phi angle, the density, the speed, and the temperature. That's basically the data what everybody is looking at. Maybe some guys somewhere have some more data. But what I find really interesting is that we have the density. Okay? So if we talk about density, we need to assume that there is some stuff making up the density, material, actual material, because it's the solar wind, it's not just radiation, it's actual matter and stuff. And if we have a CME, a coronal mass ejection, mass, it's material. So the sun is made of something, and if we have a mass ejection from the sun, there is stuff flying towards Earth. But no one really talks about the stuff itself. What is it made of? Because I'm pretty sure there's a huge variation in how it will interact with Earth's magnetic fields, depending on the constituency of the coronal mass ejection or solar wind in general, because I don't think that it's always the same. There has to be very big fluctuations. So, and all these things like solar wind, solar activity, they will impact Earth. And as I have shown in this last presentation, how I make a comparison between Earth and the layers of Earth and the atmosphere.
Exactly.
Yes. And in my paper in 2023, I wrote about, I think in my last talk, I also talked about this, that fluctuations in solar activity might have influence on the height of the atmospheric layers, but maybe also on the amount from 7 to 8 to 3 or whatever, or if there's a huge blast, none at all, which would be a very bad thing. So when it turned out, in 23, I made this paper, and a year later, I stumbled across this paper, Long-Term Oscillations and Trends of the Mesosphere derived from 60 years of standard phase heights measurements over Europe. An update. Yeah, and actually have to maybe put this here. Changes over 60 years, shrinking by 300 meters. That's interesting. So it really does it. Yeah.
So you're saying that the energy input from the sun is changing the size of the plasma sheaves around our Earth's electric capacitor?
Yeah, I think it's not only the energy input, which, in my opinion, is the only thing that really can create those layers around Earth.
Yes.
Yeah.
Like the sun has also layers, and
Yes.
I think the arrangement of the planets where they are now, it has to do with the layers of the sun's atmosphere as we go further out.
Oh, absolutely.
It's also about what is coming from the sun besides the normal radiation and stuff, like the actual material that gets dumped on Earth.
Right.
This will also have influence on how weather is influenced, and like the induction into Earth's crust and all these kind of things. So it's not only the energy itself, it's also like the actual surroundings or the environment. Because like after all the planets, our solar system is a bubble, and we are confined in the atmosphere of the sun, like which is after all a pressure chamber. Like our solar system is a pressure chamber. And the pressure is dictated by the activity of the sun, and the sun's activity is dictated like the step down pattern in electricity. What is it?
What you're saying? Yes.
Yeah,
yes.
Like and we are connected to the next bigger one, and to the next bigger one, and after a while we are connected to the center of our galaxy, which is furthermore connected to the next bigger one, so to say, like in a fractal matter.
Super clusters. And
yeah, it's just stepping down, like the whole thing.
the Russian doll theory.
Yeah. And that's also like many people don't really understand that that's the height of the atmosphere. Like if Earth would be a perfect sphere, which it isn't. So the atmosphere also, like many people know that there is a huge bulge in the ocean where the water is much higher or more than at the northern pole. Yeah, but it's the same with the atmosphere.
Makes sense.
So in other words,
It does.
So in other words, there's 8 or 10 kilometers, or 8 to 10 kilometers of atmosphere height no one talks about, which is here. And the funny thing is, like, I'm originally from Switzerland. I grew up in Switzerland and lived the first 30 years of my childhood in Switzerland. So I'm now here. I'm spending the second 30 years of my childhood in Finland. So maybe I will grow up even once. But anyway, the thing is, like, I was always fascinated when we came up here for summer holidays, and I looked at this at the sky. Maybe it's interesting for you to know that about the clouds and weather. That nowadays I'm talking quite a lot about them. But the thing is, when I was a kid, and we were driving with a car from Switzerland to Finland, which was a 2.5-day trip. I had this little pile of weather books on the back seat, and later on, as I grew older, I had maps. I always knew where we are. I knew in central Germany there's like this mountainous region, and then we go on and we approach the coast. So I knew where we are, and I had these weather books. So I was watching out of the car, observed the weather, and read about the clouds and how everything forms. So it was many years before we had internet. There was no windy application where you can check in real-time radar and lightning and all these kind of things. So I have been fascinated by weather ever since. So it's not a new thing, but now
seeing you put this graphic up right here, that fits everything I know, but I've never really thought about it until you put it here. My expectation was, yes, that the layers of the atmosphere are all equal. Of course they're not. Of course they're not. I mean,
yeah. And I was fascinated every year when we came up here to the north, and I was looking at the clouds, or like basically at the sky, and I always thought somehow it looks that you can almost grab the clouds. They seem to be much closer to the surface than in Switzerland. And I thought that, maybe it's because of the Alps and the other Jurassic mountain ranges we have and all this kind of stuff. Yeah, maybe they have some influence on that too. But apparently, like if you go from somewhere here up to here, there is already a few kilometers of difference
What do
in
the
the
red
height of the
lines?
atmosphere itself.
I'm sorry if I missed this, Stefan. What do the red lines mean in your graphic
The
there?
arrows.
The arrows?
I just found this somewhere. This was the best and most simple depiction of what I was searching for. And maybe this, I don't know what those red arrows mean, but
Well, if
maybe some.
if you understand that there is a toroid of energy around the Earth, a slice of that toroid would depict exactly what those red arrows depict, that there is a flow of energy, because toroidal energy goes from one pole, it goes in one pole and out the other. And that picture right there is a slice of what that would actually look like. So if we're talking heat, if we're talking energy, if we're talking EM radiation, it would all fit that model right there.
Yeah. I'm not saying that that there's something wrong with this or in any way. It makes sense. But the
I
thing
think it
is, I
does.
just really don't. I didn't make any research of what those arrows mean in this particular case. I was just searching for a picture because I'm not able to make it. Maybe I could have made it by myself, but come on, I
Just
figured
get
out
Grok.
to
Grok
search
will
for
do it.
something.
Yeah, you don't
Yeah,
even need to go to art school anymore.
that's like those arrows. They wouldn't even be needed in this whole thing. It's just about the height itself. So, and
No,
here it was very simple depicted.
and that's
Now,
a
on
big
that
And
one.
yeah,
height,
it might.
is the bulge because of the Lorentz force, where we're in the sun's current and we are being rotated according to the right hand rule, and because of centrifugal force, the atmosphere is bulging at the equators? Is that what's going on?
Mm, yeah, maybe to some degree, but I also tend to think that the bulge might be also some kind of a stepped down pattern of like Saturn's ring in a way. Like there's a reason for why Saturn's ring are at the equator, and what we have like the bulge of the water on Earth is just the same thing on a different scale, made with different elements, according, like, Earth's magnetic or electrical circuit is probably much, much weaker than Saturn's. So if we would really get juiced up, maybe we would get this kind of atmospheric layer like Saturn has. Maybe Earth would get some rings, at least for a while. I think it maybe had in the past once rings. I once read something about that there was like those rings around Earth as well, where the sky got divided. It depended on which side the sun was. So you could basically stand there, look up, and on the right side you have night, and on the left side you have day. And it depends on when it turned around,
That's
as
an
it like,
interesting idea.
yeah, you can look at from the side.
That
And
is
at one
interesting.
point it just splashed down on Earth. But I don't know. I have been searching for this.
Never
Where
thought
does
of
that
that.
reference come
That's-
from? Where does that reference come from? Do you know?
Maybe I heard it on Greg Chase channel once, but I don't really know the
Well,
source.
I
It
wonder
sounded.
because during the proto-Saturn epoch, when we're chasing Saturn into the sun's system, if you believe that sort of thing,
Hmm?
we were phase locked to Saturn at that point, which meant that one side of the Earth would have been perpetually dark while the other one was perpetually light, if I'm not mistaken.
Yeah.
I wonder if that could be where that could come from.
Yeah, like if you think about the polar configuration and these kind of things, the dots of the squatter man,
Mm-hmm.
Earth has dots like the squatter man, which are the radiation belts. So Earth is in the center, and then we have the radiation belts at some distance. So there is a certain
That's an
connection to
interesting idea.
things like the spooky action over distance. So if we have radiation belts, it shouldn't come as a surprise that there is something mimicking or like as a smaller scale thing also on Earth as well. And maybe the bulge in the atmosphere and the water is tied to Earth's radiation belts. There's just no disk. Like there's
Right.
part missing.
Whatever the trigger is for that is missing. Yeah.
Yeah, but So it's not only that Earth has a bulge at the poles, but if you go further out or like the distance grow from Earth, there are the radiation belts. How comes? So like it's
Well,
not just something.
why does an ecliptic form?
Yeah.
What is an ecliptic? Like this sheet of
There's
something
like
between
about the Birkeland currents. Like I think it was Donald Scott who explained that the Birkeland current doesn't connect like this. It's in a way it goes, it overlaps a little bit.
And it
Yeah.
and it
And it's the
connects
same-
at the equator.
Yeah.
I just
So
saw
the
that.
thing
Yeah,
is like
yeah.
it must
we
be
always
the
think the
same.
Birkeland currents go in at the North Pole and South Pole. He's like, no, the Birkeland currents from the sun connect to the Earth at the equator.
yeah, because it's a
Like-
current sheet, right? Like the sun has a giant electric disk around it, a current sheet. Is that
Yeah.
accurate?
Yep, the current sheet might be probably the diameter of the sea pinch area,
Mhm.
but like
Right.
the highest energy is in the center where
Is
we
in the
have the
center.
sun. So
And
we
the-
are like our whole solar system is not only a bubble, but the bubble is within the Birkeland current, and that
Right.
connects the sun to the next bigger thing. And
Right.
Earth, the Birkeland, like Earth is within basically the Birkeland current that connects us to the sun. So at the center of the Birkeland current that connects us to the sun, there might be something hot like a plasmoid, like the plasmoid at the center of Earth. That's how I came to the conclusion that, yeah, there must be maybe, or like there must be a plasmoid at the center of Earth, because it seems the layering of Earth's atmosphere seems to be produced electrically, and there is heat coming, or like there must be some pinching thing going on, like the
I 100% agree.
engine, so to say, where we get the elements transmutated into something, and often
Yes.
it requires heat and pressure, and you don't need millions of tons of rocks in order to get the pressure. You just need to have a confined cavity, and if you light it up and it's like strong enough, there will be pressure building up because the heat is going. Yeah.
So, and
You have
if if it's creating metal particulates like by Liner in that plasma in the center of our sun, or of our Earth, wouldn't it then be spraying that metal particulate all over the underside of the crust, which would be making its way up to the surface through thermal vents and whatnot?
Yeah.
And
Yeah.
then
Exactly.
our telluric currents and lightning strikes form this metal particulate into Earth's circuit board, the metal ore circuitry that connects the entire Earth.
Let's go on a few steps, and then we can talk
Please, go
again
ahead.
about this exact same thing, because
Stefan, you're just putting out so much interesting stuff. We can't help but stop and say, please
no,
explain
it's
more.
no problem.
That's
No
the
problem.
show.
So like we are talking about the solar wind, and I have been talking about the solar wind density, and here we have the evidence that determination of sulfur abundance in the solar wind. Yeah, it's made of something. Solar wind and meteoritic matter originate from the same nebula.
Wow.
What is a nebula? Yeah, it's a cloud. It's plasma.
Of
And
plasma.
not only in space, every cloud is plasma. And once again, that's from the same paper, we have sulfur. If we have an eruption, there is a sulfur spike again here. And the thing is, why I brought this up is my research about, we are talking about, can you see the whole title? Because I still have this stupid thing here. I cannot.
Oscillatory
Yes.
Marangoni flow, a fundamental study by conduction mode laser spot welding.
Okay, yeah, you can see it. I can't. That's very nice. So the thing is, laser spot welding. So we are talking about laser, which is light, okay? But it's very strong light. But it's still light. It's just another form of electromagnetic radiation. Like the sun. We get the radiation, and we also, like, as we just learned, we get the particles. For example, sulfur. sulfur effect on ripple formation and penetration. So we are talking about electromagnetic mechanics after all. It doesn't really
Oh.
matter if we are talking about the sun or welding because it's electromagnetic. So if we have
Wow.
42 parts per million, I guess that's of sulfur content while welding, we get this kind of pattern.
Oh,
And it is very shallow. If we increase the sulfur content to 140 parts per million, we get a smooth surface, but it gets very deep penetrated. And that's basically the same thing, once again, just other pictures. So, to my question again about the solar wind density. And we know there's sulfur in the solar wind and all these kind of things. So, if there's a lot of sulfur in the solar wind, I think it could have much bigger influence on the geomagnetic activity and all this kind of stuff on Earth, just alone the sulfur. And for whatever reason, I don't know exactly what's the thing about sulfur, why sulfur seems to be something very important. Like, yeah, I know the alchemists were very interested in sulfur.
Yeah.
So it's also about like if you talk about alchemy and the spiritual thing of alchemy, which you cannot like alchemy. The true alchemist is also a philosopher of nature because that's the whole thing, because it's including the entity itself. And for example, in Finnish language, uh, there's like if something is broken, you say, or like if how does there's a saying "kaikki on rikki." It means like everything is broken. Okay, but you can also translate it into everything is sulfur because rikki
really?
on sulfur. Yeah, it's the same word. So this
Interesting.
word either means something is broken or it's sulfur. And I've been thinking about this, and somehow I came to the conclusion. Yeah, now we go a little bit into the philosophical side. Sulfur is a very important element in like our whole thing of life. It's
Yeah.
a basic element of life. Without sulfur, there's no life. Okay, and in order for something to be either broken or still like in good condition, there has to be someone to make the decision or the approximation if it's still broken or like is it broken, there has to be some kind of an entity to look at something, which is life either sees something as broken or not. So in other words, the whole saying everything is either sulfur or broken implies that there has to be some kind of consciousness, intelligence making the decision. I cannot figure out the better word for that, but if something is broken or not. So it's very interesting how deeply embedded in a way the word sulfur is in Finnish language, because everything seems to be sulfur. Yeah. Without consciousness or life, there wouldn't be any two meetings here.
Well,
And
my
my mom
daughter,
is a little bit.
this is really profound, Stefan. My daughter is I have an autistic daughter, and one of the biological reasons for it is because she can't do methylation, which is, from what I remember, a sulfur process. So when you say that sulfur is incredibly important for life, not just for, laser spot welding, right with you. I think you nailed it. I'm gonna have
Yeah,
to look into
sulfur
that
is
more.
like, as far as I remember, like if there are like few elements in alchemy that are related to somehow the conscious state of a human, or how to put it.
Oh,
And like
Oh
there's
yeah,
like
yeah.
sulfur is the spiritual, is the element of spirit in a way. And if you take salt, it's the element of the ego in a way. Or yeah, it's like the person itself. It's not yeah, salt is more the personalization or like the ego.
Right.
more, yeah, but sulfur is more like being open, like the spiritual part
I'm
of the entity.
we need to talk. Excuse me, Stefan, a sec. Matt, we need to talk to Jeffrey Drum about the significance of sulfur in ancient Egyptian culture. I'm gonna bet we're gonna find a link with that.
I agree. I got a question about this though, the patterns there. Certain stars probably produce certain kinds of chemicals more than others.
Mm.
And if ours is primarily producing sulfur, we're getting certain land formations as our planets form. But if you're around a star that produces something other than sulfur, it seems like your landscape would look completely different according to this. Like if you have a different sort of catalyst going across the solar wind and entering the planet, it's going to be making different arcing patterns when your geology is formed,
Yes.
isn't it?
Yeah, yeah. Yeah, it's
That's interesting.
After all, like we are talking about when we're talking about the Birkeland currents, then that they are generally two strings that are rotating. It's not one. There's like generally two, I think.
Right.
Like often there are two.
Braided pair.
So the thing is, like after all, like if we are talking about the material world and elements and stuff like this and electromagnetic interactions and these kind of things, then we can boil down the whole matter thing and its interactions with its environment basically to the pH. We have something that is acidic and we have something that is what is it? Amaxian, and that's Finnish.
Yeah.
What is the opposite of acidic? I don't get it into my mind in English language.
Alkaline.
Yes. Alkaline. Okay. So one is an electron donor and one is a receiver.
Right.
In other words, if we have material like dust clouds in space or stuff like this, maybe or probably they get first arranged due to their electromagnetic properties, which are going back to the pH of the materials themselves.
Think of this.
We have the sulfur, which is very interesting, at least here in Eastern Finland, for very interesting reasons. I will go into that later on in this presentation, if I get there. Let's see. And also, like I have shown in my last presentation, aluminium, which is 8% of Earth's crust, which is an alkaline metal. So there is already we have two materials. One is heavily acidic and one is heavily alkaline. And like in my last paper that got released where I talk about the swamps and stuff like this, we have often limestone and there is like acidic water, and yeah, it's like a battery. It's like Jeffrey Drum, battery stuff.
Keys of pyramid.
Telluric currents. Yeah, you got the battery. So all the swamps, not all, but many of the swamps that I have found where we have peat, it's not only the swamps themselves, they're like just alkaline swamps, for example, but I'm talking about especially peat swamps or peat wetlands where we have peat, which brings the acidity and the alkaline environment. So, and put water into the whole thing. It's just like a battery. It's the same principle, an alkaline battery. It works at the very exact same principle.
Are you saying swamps?
Yeah, swamps.
Swamps. Okay.
Yeah.
Well, and
peatlands.
So another thing, Stefan, is when you started talking about all of the sulfur coming out, I'm like, where does sulfur come from? Volcanoes. The discharge from volcanoes is sulfur dioxide. In fact, when we actually get sulfur to use in our chemistry, we get it from vents at the bottom of volcanoes.
But we also get it from the sun.
Right. Yeah. I mean, think of
the solar wind. Yeah.
Think of
it's not only the solar wind.
Exactly. That the solar wind hitting the earth and interacting with these sulfur dioxide clouds that are put out by volcanoes. Is that going to change the electromagnetic nature, the telluric currents of our planet? Yeah. Yeah.
Yeah. Like, it's not only that there's sulfur coming out of the volcanoes, but there's also sulfur coming from the sun every day. And especially when you have CME, there might be millions of tons of sulfur coming towards Earth, and they will interact with the magnetosphere, ionosphere, and further on. So
Exactly.
I have made several videos where I talked about volcanic ash plumes being like antennas for clouds, where we can find on the discharges that go back to the volcanoes. Maybe I have to send you a link about this one Popocatépetl volcano video, where you can see how the discharge initiates in the sky. First, there's a glow in the sky, and after that, the volcano erupts.
Stefan,
and I don't think that's a coincidence.
No, it's not.
So, and the other thing is, go on.
I'm actually watching it. The camera that is facing you, if I were to turn it around, there's a monitor right behind the camera that is monitoring that volcano. There's a live camera. Yeah. I've been monitoring it for like months now.
That's a very interesting volcano.
So is it getting more active?
Yeah. But the thing is, I made videos about when I tried to explain that the volcanic ash plumes, not only due to the ash plumes themselves, because they are like charged particles, they are hot, so they are charged, and they are whatever material they might be. But there we have the sulfur dioxide gas that rises up to a certain height, and this might be the trigger for atmospheric discharge. And this paper, like what you're looking at, those sulfur effects on ripple formation and penetration, this was one of the things I tried to tie into my whole theory. And some time ago, I stumbled across a paper that was talking about shipping.
Shipping?
And I thought, shipping. Ships.
Like ships on the ocean, okay.
Yeah, like big ships, like transport ships, tankers and stuff. And they were making research somewhere, I don't know, maybe Shanghai or something, somewhere in the East. I made a video about that. But the thing is, due to some regulations, they had to bring down the sulfur content of the fuel they used in the shipping.
Why?
So they had to use new fuel for the ships that contains less sulfur. And it turned out, after a while, where the corridors are, where the ships are going into those huge ports, probably the biggest ports on Earth, the lightning over those ship lanes decreased. So they lowered the sulfur content of the ships, and the lightning decreased. So in other words, my theory about volcanic ash plumes being like antennas due to the sulfur content seems to be in a way confirmed just by reading some random ship paper about lightning.
Crazy.
That's amazing.
That's crazy.
And if you just
amazing.
think,
and you know,
the amount of.
Oh, go ahead.
No, just go ahead.
The image here with the clear ripples and the no clear ripples. To me, the one on the left looks like the rickshaw structure. And,
yes.
And the one on the right looks like something you would see on Mars. Now, because Mars has no volcanic activity, I assume there's not much sulfur.
Maybe there's even a hexagonality visible in that. There is a corner, and here it somehow fades out. But if you want to drive your pareidolia, you can see a hexagon there in the center. It's not a perfect hexagon, but
does Mars have a lot of sulfur?
Mars seems to be more the iron thing. Venus is the sulfur ball in our solar system. Venus has a lot of sulfur.
That's its atmosphere. Yes, it is.
Yeah, it makes me wonder if Venus has any rickshaw structure-looking discharge points like that.
Are you saying rickshaw?
Probably.
The rickshaw structure. Do you know what that is?
Right chat. Go with rickshaw. I love rickshaw. We're gonna call it the rickshaw from now on.
I'm going rickshaw. By the way, you can tell who the brains of the operation are here.
We're staying with rickshaw. That's wonderful. I love it.
Yeah, it would be interesting. Like if somebody would make a research about the depth of the research structure, that would be something very interesting. I heard that there are some water sources within the research structure, but I'm not too sure about that. Would it
Jimmy
be
Garcetti.
okay if we would go on? Because I think there's like still some pictures left of my
Sure.
yeah, like again, like my microwave pictures or my microwave experiments are basically representing Earth is the pebble, and the microwave, the energy source, is the sun, or why not the rest of the universe? Now, this is one of the examples. So obviously, it is cracked in half, and there is occurred some kind of a ball there. I don't know if it's vermiculite. It's black. But anyway, it didn't take too long in order to get this done. I didn't have to kill any dinosaur. No meteorite strike was needed. So it's just like induction energy on the microwave scale for a few minutes. And in a way, maybe vermiculite could be one of the contributors to the growing Earth, because there seems to be vermiculite all over the place. In some places, there seems to be more. And if we have strongly enough telluric currents that could eat up stuff, we could probably experience like
That's a really
growing
cool idea.
So you're on
Yeah,
board
and
with the Earth getting bigger.
yeah.
I think I am
And the
too.
bigger it gets, yeah, like in a way, I think like about the theory that if you could produce a brontosaurus and put it in your backyard, it would collapse under its own weight. Okay.
Yeah.
In other words, the gravity, the gravitational pull of Earth has changed over time.
Yeah.
We know, in a way, learned from Wolf Thornhill how gravity is tied to the charge of things. So the more charge something has, the more gravity it exhibits. So we probably need to assume that back in the days when there was dinosaurs, Earth was much smaller. And
I think it's because we were attached to Saturn, and then we got captured by Sol, which is a much larger energy source.
Yeah, but every time when there's like a huge energy input, basically it doesn't really matter if it's Saturn, Uranus, or Jupiter, or the Sun. But if Earth gets juiced up, there will be stuff like happening, like probably we see on the picture, and Earth seems to grow continuously because every volcanic eruption, there's like stuff coming out. It just depletes on the mountain. But most often, nothing really happens. It's just like the mountain grows steadily. Iceland is growing steadily, like sometimes a little bit more. We get new islands forming. Everybody knows that the transatlantic mid-ridge is like the plates are like they're going apart all the time. So if they are like going apart all the time and there's no hole, there's just still stuff there. It's just growing. It's nuts. You don't need to be a scientist to understand that if they are going like this, it's growing.
Yeah, it's not moving. It's moving, but yeah, that's your point, is that it's growing. It's not just shifting. It's not doing this.
Yeah,
it's doing this.
We never lost any part of any land anywhere. Yeah, the biggest earthquake, like, or the big one in Turkey, like not a single land part got lost. No, they just got apart, and there was an olive orchard. It was like, let's say it was this wide. It was this wide. Yeah, there was just no trees in the middle, but there was still land. So now they're just with their olive yard, but now the olive yard is double the size they had before. So nothing disappeared. It just grew bigger. So
for getting a steady stream of material coming in from the sun and being created at the plasmoid at the center of our world, that's a lot of material being added to the Earth every day.
That has to go somewhere.
Yeah.
Right.
Yeah, it will come out. Like true change happens from within. So now to something completely different. Like this is a little like Monty Python. We are not talking about the large this time. We are talking about the oak from the Kalevala. Like in many ancient mythology tales, they are talking about the big trees and stuff like this.
Yggdrasil.
Here we have the axe. That's the tree, and he's going to cut the tree down. We have the sun and the dragon spitting water and all these kind of things. And here you can find the source of that picture. I just tried to find a funny picture about the tree because let's put you up there here. That's from my very first paper I ever made. The structure of the world according to Finnish mythology. So that's a very, very simplified depiction. And I think the tree from the Finnish mythology, Kalevala, the oak, is actually representing the auroral funnel. And you can see the stripes here. And probably these were all like the branches of the trees and the little, like when they were discharging, these were the leaves.
Yeah.
And in the same paper, and I use it later again, because this little part of the Kalevala, and the Kalevala very big book, it is totally comparable to the Bible or Quran or whatever else big book. And it's just sad that don't know that. But anyway, this is the thing, those few lines that brought me to the understanding of the origin of peat, but that's not basically the talk of this. So at the third time, he could fell the oak. The picture we just saw is where he took the axe and felled the tree and shattered the world's sallow and bring down the 100-leaved. The base he thrust to the east and the top he lowered northwest. So the picture here, that's the surface conductivity anomaly of Fennoscandia. Here we have Petersburg approximately, Russia. And then it goes through Finland, southern Finland, to the coast where we have a nuclear power plant. I leave it here. And then we go north. And here on this side, the blue parts, I think there are the areas with high resistivity. And this is the red parts are high conductivity. In other words, the energy goes either like up or it goes down. And here we have a very interesting area where we have high conductivity and high resistivity side by side. And here, this one little red dot is the copper mine of about 40 kilometers from here, Outokumpu, where I have been talking about many times. So I think in the Kalevala, we are talking about the base of the tree, like the Birkeland current, casted to the east. So we have a line that goes to the east and northwest. This is northwest pointing. So I have been talking in my last presentation about the ancient people saying that if you see the auroras, if there's an aurora display, wear a hat. I wear a hat. There's auroras in the background. Anyway, if that speak silently, don't whistle. Don't make the auroras angry because they can come down and kill you. Yeah, it sounds crazy, but I have this electromagnetic or surface conductivity anomaly here, which has a perfect fit to what is told in the Kalevala. And as I tried to explain in my first paper, the Finnish mythology structure where we have the pillar, which is quite likely the tree that fell or what is cut down by this one dude, probably a god. Yeah, and it really seems to the perfect directions in which we have the surface conductivity anomaly, and this is the Fennoscandian conductivity anomaly, and this I've been showing the last time. And this whole surface conductivity thing here seems to represent the imprint of the polar cusps, which we have up here. So this area might have been smashed down onto the surface of the Earth. So the tree here we have, and as I tried to explain earlier about the heights of the layers of Earth's atmosphere, that they can get compressed, change in size and numbers, so to say, the numbers of double layers. So if there is a huge eruption, like a blast from Saturn, Sun, or whatever, Venus,
right,
with
or
all
some galaxy far away,
it could be anything.
Yeah.
I just think that we have here this red dot here, like you can see it here, maybe better. That's the copper mine, Outokumpu, which is not far from here. Yeah, so Venus.
Oh.
And then we have the copper. You don't get the copper without sulfur. So this could be that this whole thing got created as one of his very close approach, and we went through the tail of Venus, which was probably a huge dust cloud made of sulfur, and some atmospheric transmutation of the elements, metallizing process occurred, and some of the stuff rained down to Earth as metal, which was the copper. Some rained down in the form of brimstones, told in the Bible. They were still red.
Yeah.
We have copper and sulfur here in Finland, and it's just like it's just, if these are all coincidences, I would be very surprised.
Yes.
So there's
Like,
some sort
They're
of.
just coincidences.
So
No,
let me see
no,
if
they're
I'm,
not.
if I'm
No.
hearing
and
this
even
right.
the copper ore itself, it's this kind of olithic copper ore, and olithic means spheres, like the spheres you have in your desert. But the spheres you have in the desert seem to be iron. And so, in other words, the spheres you have in your desert, they might be originating from Mars. And the
Right.
spheres we have here in Finland in the copper originate from Venus, because we have the copper and all the sulfur. Yeah, these are Mars tears. They are probably made by the same principle, and probably they just fell into water. Because I
So-
assume when these kind of events occurred that there was very, very bad weather, and it was probably a slight breeze going, heavy rain and fog and all this kind of stuff. So it wasn't on a sunny day. These things happened. So like about stuff coming from above, which was very hot, and it came down into like lower to the surface, and maybe it fell into water, or it's just like through heavy, very heavy fog, and then dropped into the water or into mud or in, like,
Could be any of that.
So-
All of that.
yeah.
Wow.
So would there have been arcing?
But I don't know what really happens when the auroras touch the ground, but maybe we'll figure out in a few years.
From
Who
my
knows?
Or in a few months after 3i gets closed.
Yeah,
Maybe
when
next
3i.
week.
Well,
Next week, because now the sun is turning in with very big sunspots. We never know what's going to happen.
Yeah,
Is
and
that-
I don't know, but the clouds look weird to me, and they've been looking weird to me for like the last couple of weeks. I sent some pictures over to Ben.
Yeah. We
I
will
don't
still
know.
look at some clouds. I will show you some clouds in a while.
Oh yeah, let's look at clouds. I forgot all.
Yeah, it's not about the same thing. That's like the auroras touching the ground. And if you look at the form or like the arrangement of the auroral of the metal occurrences, they are bands, literal bands like we have in the auroras. I could have used an own picture, but that's very old, like, And we have vortices. And I, like in my last paper, there is a paper about, I found a Finnish, like there has been some Finnish person involved in that paper, that these are actual vortices and they always spin in the same direction. Yeah,
Mhm.
because they're coming down to Earth.
Yeah.
And this vortice was recorded, like that's a screenshot from a live stream over Iceland before the big eruption series started. And
Could that be the termination point of those filaments coming off the sun that connect to the Earth?
Yeah, the thing is, like, the question is, or the thing to understand is that what keeps the auroras up there?
that's a good
Why
question.
don't they come? Yeah, so
Because-
it's the same question of what keeps the clouds in the sky. Because, one rain cloud, it weighs like millions of tons, and it just doesn't fall down, only when it wants to.
Double layers.
Yeah, So, in other words, like if you ever have experienced a foggy day, and if you next time when you have a foggy day, you go outside and then you look at your feet, and maybe one question pops to your mind is like, where heaven starts. Like there's many religions, like especially Christianity, like you really have to hope to go to heaven after you die. Yeah, dude, heaven starts just where you stand, below your feet. So that's where heaven starts. And if you want the proof of that, wait for the next foggy day. You go outside and you stand in the middle of a cloud.
Yeah,
right.
Which starts where your feet are. So that's where heaven starts. You can't basically escape it.
That's a
It's
clouds
simple.
clouds are lower in the morning. Is that because we aren't charged up with as much positive energy coming off the sun yet?
I have been noodling about fog because, like, when I was making research about the whole peat and swamp thing and all these kinds of things, and then I found interest about in plasma resonance, plasmon resonance, and it's basically
Plasmon.
they were like plasmon resonance.
Yeah.
I tried to include it into this presentation, but it was
Tell everybody what a
anymore.
plasmon is. Tell everybody
Yeah,
what a
the thing
plasmon is.
Like what I have learned about this, they take some material and they will shine a laser on to the material, and then they figured it depends on the material, on the light source, and all these kind of things, that they will start to form a layer above the material. And as soon as you switch off the light, the layer disappears. Yeah, and that's basically very, very simplified, the plasmon thing. I can send you some links about plasmon resonance. And yeah, of course, it's in a laboratory. It's very tiny, like those things there, like in some little machine and stuff. But
that sounds
Earth
very
is a very
familiar.
little
Like
thing.
that sounds like Gerald Pollack's easy layers. You turn on light, specifically red light, and there's a layer that forms.
Yeah.
That sounds exactly
Yeah.
like what you're describing.
Yeah.
Well, if the night side is negative and the light and the sun side of the Earth is positive, and that's why they chase each other and make wind, it would make sense that on the night side the atmosphere would be closer to the surface of the Earth because it doesn't have as much charge going into it, does it?
Also, it's like the telluric
gotta be
currents
something like
start
that.
to flow as well. Yeah. And the thing is, like, it's also like back in the days when I was fishing very much, I was very early in the morning, and I learned that in certain conditions, when the sun is rising, there is this kind of a shock wave going through the atmosphere. At a certain point, at a certain angle, when the sunlight starts to hit the Earth, it starts in a way to push the air. And a few times, maybe 2 or 3 times, I really experienced this exact moment at the rise of the sun. And there, all of a sudden, a slight breeze, and it was over. It's just only a minute, maybe even less,
Really?
and it was over. And I was blown away. I like, because it was totally like there wasn't any wind. And it was blue sky, like a perfect summer morning for fishing before going to work at somehow 4:30 in the morning. And perfect conditions, and all of a sudden a slight breeze from the same direction, from where the sun is, like at the horizon, just pushes gently through the atmosphere, and after that everything is as it has before. So for me, this was proof that something is going on as the light hits the Earth and the layers of the atmosphere. It seems to, in a way, kick things into movement, at least a little bit. And this also might relate to the maybe pressure of the solar wind as the our bubble of Earth gets deformed as we spin. I don't know. There might be pressure.
It could be the pressure. It could be, it could be a physical pressure, a mechanical pressure. It could be electrostatic pressure, an electric pressure, magnetic pressure. It could be a lot of those things. But now that
because the layers get compressed, so the air will flow at least to a certain degree into the direction, it will escape.
So now what we need to do is, since this is going out worldwide, and now people will be aware of that, it would be fun to see if we get some feedback from people who are right on what's called the Terminator line, right where between sun and night, and see
every morning everybody is at this. Every morning everybody is at this terminator line.
You would think that more people would notice that. And now that we've put that out there, it'll be fun to see if we get some feedback, like in the comment section, if people have felt that. And make sure, if you're going to make that comment, make sure and tell us which way the wind is going, or the pressure wave, if you can feel it. If it's, it's going toward the sun, away from the sun, whatever, where you're at.
As far as I remember, it is basically from the sun, away
from the sun, right?
Basically, as far as I experienced. But the thing is, I have been thinking about, like, local like buildings, big buildings, or trees, or the shape of like the area where you are. If the whole atmosphere starts to move a little bit, it's not really wind. I just think it's
pulsing.
So yeah, it's just like it gets washed and then it will settle back down to where it was. So in other words, like if you are like in a river valley, if you're in a bend of a river valley, and you experience the same thing, of course, the air will follow the river valley. In other words, the direction of the wind, what you experience, might not be the general direction of the whole thing moving. Like this is like, or if you stand beside a big building, it's really hard to say if the wind is really coming from that direction, because I'm standing in front of a building which is 100 meters long, so the wind will follow the wall of the building. So that's the thing about the direction of the wind. But I remember that it has been from the sun, away from the sun, which would make sense in a way, because how the sun rises and how the light hits the earth.
So this would be really useful for people in very, very flat areas with like no buildings around. So like if you're out and about in the countryside.
Yeah, in the desert.
In the desert, right, where there are no mountains to create vortices, eddy currents of wind, and just stand out there at sunrise and see if that happens. Yeah. That's a great idea, Stefan. Great.
So, like in the desert might be the best place, because generally there are dry places. So,
well, can't we see this happening in the jet stream?
Probably they are too strong in order to get influenced by this little. Maybe I don't think so. Maybe
because the jet streams move in a certain direction, don't they?
East to west.
Yeah.
East to west.
No. Is that right? No, it's west to east.
It's the same direction our Earth rotates in.
Oh, then it's east.
It depends where you watch. They probably move in different directions at the equator as they do at the poles.
I've got the jet stream on a map on another monitor right over there. I'll check it later.
Compare the poles with the equator.
That'd be weird if they counter-rotate.
Yeah.
Well, okay, I'm going to take this moment. Go to earth.nullschool.net or windy.com, like Stefan brought up. Either of those have wind maps, and you can check. You can go on different layers, different height layers. They're called, I forget what they're called. It doesn't matter. They're called pressure layers, and you can see the wind patterns at different layers. And they go in different layers.
Do you know how meteorologists call atmospheric double layers?
Huh?
What?
They are pauses.
Cautious.
The tropopause.
Heliopause.
Pause. Yes. Yes. Exactly.
That just use a different name for double layer.
Exactly.
Yeah.
I completely agree with that.
Pauses. Yeah. It's exactly the same thing.
It is.
But since they are not
completely agree.
Since they are not called pauses, they are not related to any electromagnetic mechanism, so they remain a mystery. Yeah. Okay. Now.
Yes, continue, please.
We were talking about sulfur, how it can penetrate stuff deeper, and this seems to be maybe the polar cusp smashing down on Earth, where we get the sulfur and the copper from.
Wow!
So
I love that idea.
Which was the word tree, and also like those deposits seem to be banded in structure and vortices and all this kind of stuff.
That's such a cool
idea. We have more evidence for this. Now we have the MOHO. I don't remember what's the full name of the MOHO. It's some anomaly or like some double layer within the Earth's crust. And where we have approximate in the area where we have the surface conductivity anomaly. Here, the moho is very deep. Yeah, there's a lot of sulfur here in the crust. Okay. If we go back to this other Maragoni effect in sulfur welding. Sorry for that scrolling. It just takes a little while. Now we are here. Yeah. A lot of sulfur. We get really deep penetration of the material. We have a lot of sulfur here in Finland, and no one really knows where it's from.
Really?
Maybe it was a huge electrical discharge that formed the surface conductivity anomaly. The ancients told about this. It seems to resemble the polar cusps. We have the bands and the vortices, and we have a very deeply penetrated area also at the same place. So it all seems to bind together. And maybe the moho is just a layer of molten silica in the crust of Earth, and here there's like obviously.
Is that your microwave?
Yeah, that's my microwave. This pebble didn't really withstand too much microwaving, but it was very interesting. The glass here started to melt, and when it melts, it starts like it starts like a chain reaction. It gets really, really quickly, really hot. Yeah. So as long silica isn't molten, it doesn't really do too much. It can maybe even be used some kind of as an insulator. But once it's molten, then the stuff starts to happen. So maybe there's some molten silica layer also beneath Earth's surface. Many lavas contain a lot of silica. And since you were talking about Earth's plasmoid core, also with Steve Smith, which was very interesting.
Wasn't it? That was pretty cool.
Yeah. This is the only picture I added because we are still going on to Mars things later on. This is in one of my papers. Wall Thornhill's repellent core here on the right. We have a geoid. And if we have Earth, there is about 12,700 kilometers from, there's place for a plasmoid at the center. Mm-hmm. And if you look at this lab plasma thing here, where those tendrils touch the surface or make it through the surface, it's where we have the volcanoes or geothermal activity. So this is what I think. And here I somehow say that the Birkeland, the poles and their connections to the sun via Birkeland currents is not part of the picture. So this is just basically about the core and geoid. So basically Earth is a geoid just alive. And many geoids, they contain water when you break them out. And since we have the surface conductivity anomaly, the red stuff is highly conductive. This seems to be resistive. So the energy may go more up on this area. So it will create a low pressure system where we have the conductivity. It will go down, it will rotate like this, and it will create a higher pressure system. That's why we have very strong high pressure systems here in this area. And this configuration also is the reason for why many weather patterns, they go between Sweden and Finland northern. And here Oulu, at this area, we have very heavy thunderstorms because here we have the boundary between a very resistive and a highly conductive area, just beside the shore. So it's a perfect.
Right. Do you have, and I mean, we can measure that. Do you actually have more storms on that layer?
Yeah, it's the thing is that local people from the city here, many of them know that, there's very rarely thunderstorms here. Yeah, they can come over the lake, but as soon as they reach, basically, as they come closer to the city, they dissipate.
Huh.
Many people know that. Yeah, but I think it's because the hill here in the city, it's basically, it must almost contain a lot of copper. And the plasma rock side, which I still will show you later, there's a old copper mine there. The city is approximately here, so it's highly conductive. And here we have the big copper mine. So it's all conductive. So when weather, it's very often that weather comes from down here. Yeah, because this is spinning into this direction. But then when it goes on here, very often it dissipates about here. And when I moved to Finland, I lived here at the shore. Here is Helsinki approximately. I wondered that how is it possible that the weather, like the bad weather, just comes into the land, like over land, and just then disappears or like dissipates after it made some 200 or 300 kilometers onwards to the land. And there are no mountains or whatsoever, and the shore doesn't really seem to do much. So it took me a while until I realized, yeah, maybe it was after I found the electric universe or at the same time. But the thing is, after I saw this line here, and this, it's not visible here, but here it says SFC.
What's that?
And the SFC starts here and ends here, and SFC stands for Southern Finland Conductor.
And that's what that red band is.
Yeah, that area, that's the Southern Finland Conductor. And if you go to search for papers about the Southern Finland Conductor, you will figure out that, yeah, they're talking about different kinds of rocks and base rocks and these kind of things, but not one single word about any metal.
No metal,
no copper
just sulfur.
mentioned, no iron mentioned, no sulfur mentioned, just different kinds of rocks.
Oh, no sulfur mentioned. Okay.
There's like maybe, I don't know, graphite is often mentioned. They seem to be focused on graphite. Yeah, it's conductive. Yeah, but there's like copper mines and stuff here, gold, all these kind of things. Not mentioned in the surface conductivity. Southern Finland Conductor papers. Also, this whole surface conductivity anomaly paper, and I've found some compilation, no metals mentioned, which I find very interesting, and I don't think it's a coincidence. But anyway, is there more evidence of a possible electric discharge event from the past? Yeah, that's from the Plasma Rock side shore, looking at some clouds in the distance. So here we are at the Plasma Rocks. I call them, it's officially Kuasalo. It's at here, if you would go over this little here, on the other side, there is the river. And here are the tetrahedrons, and on the right side is the crater. And I could make many videos about this site. So here, I think we have a crater from an electrical discharge event.
Wow.
And it's about 2.5 meters across. And it's also difficult to take a good picture of this for some reason. It has to be good light.
It is hard to see.
In order to get the color. And
you can see it, though.
This thing here, yeah, it's round. It's more round than it somehow seems. And the roundness seems to be that this material has been soft to some degree. And yeah, you can see like maybe thousands of craters just on this little rock.
Those little micro craters, yeah.
And here we have the comparison of this crater we just looked about and the Richard structure.
Rickshaw structure.
Yeah, and here's maybe a better comparison of those two. You know,
Yeah.
They have some similarities.
They do
just
indeed.
Along with the color.
They do indeed.
I wonder if there's any sulfur within the Richard structure too. I don't know.
We're going to look
looks
that
like
up.
it just looks like a petrified Birkeland current.
Yeah.
Double layers and everything.
And that's the same thing, black and white. And here we have Czechia, like from Google Earth.
Yep.
And here we have some mining operation, and this is, I think, the area where we have also some volcanic activity. I don't remember the name of that. That's the Eye of Siberia I found some time ago.
Where's
it seems
that
like you
at?
could forecast.
I can send you the coordinates to this. It's about 4 kilometers across, if I remember correctly. It's on an island. So it's probably...
It seems like this would be... It seems like this would be a good way to scout for mines.
Exactly.
I think
You can
I
pretty
bet
much
you can
guess
find
where the metal's
all
going to be.
kinds of stuff here.
Yeah.
Yeah, for sure. Yeah, my mouse is a bit broken because it doesn't really want to scroll. That's from the plasma rock side, and that's maybe a half meter long, maybe.
Oh wow! Look at that Hudson Bay.
Hudson Bay. Yeah, to me, there seems to be some similarities between those two.
Worth looking
yeah.
into, absolutely.
So it doesn't really matter how big the rock is. If you see the same picture, it might have been produced in the same manner.
Well,
Electricity scales.
Everything scales.
Yeah. Here we have like 10 centimeters. That's for scale. That's rather small. Here we have craters, a few. Molten metal, which might be aluminium. We have the tetrahedrons, several of them. Quartz also within here. And in a way, I noticed that I started to think, yeah, that's a very gentle way to say like this, but I came to think about that quartz seems to be, hold your seat, petrified water.
Petrified water.
Oh,
Yeah,
that's
due to its abundance and stuff like that. But anyway, I unfortunately couldn't find the picture, but I had like the seams from one tetrahedron to the next on certain occasions. Probably you can see it. If you look really close, it looks like welded. There seems to be like a welding seam between.
Yes.
Yeah.
I can see that
there seems
there.
to be metal, like it would be welded, like with a first day welder skill. But it seems to be welded. There seems to be metal between this tetrahedron and those in the back. And that's like, that's a half a meter. So that's maybe 1 square meter, that thing. And you can find all these kind of things here. And if we would know what exact materials we are looking at, I guess the yellow stuff in the background is sulfur. There is for sure some too. We have aluminium, we have like quartz and many things. So if we could make investigations just about this little area, it would be very interesting.
Speaking of making investigations, I know I told you that I've got an SEM scanning electron microscope access to it, that I'm taking your samples down. So actually, Stefan, I've got a lot of samples from you. That was the box that I showed earlier. That's actually a box of rock samples from Stefan that he sent me.
Oh, wow.
Last year. Stefan, it looks like I can do one at a time. Which one do you want me to start with?
I think let's just maybe I have to check your video and then I can tell you exactly, because if you just have one,
I'll send you
an
email. I'll take a picture of each sample, send you an email, and then tell me which one you want me to zap.
I can check your video, because there you show all those rocks.
Let's do that.
I think I already know which one of those.
Yeah, I want to know, so next time I head out there, I'll make sure you get it.
Yeah. So here, pedaling around in the forests,
wow,
you stumble across those pits where they dig sand and all these kind of things. So not only do we have in some way repetitive pattern, dark patches here, but we have also sand deposits on top of sand deposits, which seem to me that this top layer might have blown in by wind. If we think that this has been water or watery and stuff like this, so it's very hard to think that the glacier would have carried the sand here like neatly in this kind of a manner. This seems to be like a low pressure bubble behind something.
Yeah.
Well, the other thing, the colors indicate that there are different mineral contents. Is water going to segregate the minerals? The water is going to mix the minerals. It almost has to be some kind of electrical discharge nature to separate the minerals.
Yeah. So, and if the thing is, like, if this would have been dry and there would have been like strong winds, there wouldn't have been formed this kind of layer. But if there's like wet sand, it's much more sticky, so it doesn't get blown away by the wind. Maybe it was so strong that it took away a little bit from here, but filled it with the new layers. So, but if this would have been dry, like the whole thing would have probably blown away. So that's what I think. That's how I think
Right.
that this might have been saturated with water when this top layer formed. And as you can see here in the background, there has been probably much more on top of that, because I'm like looking, that's the edge of the mine, and here it's ending, and in the background there's, maybe it has been continuing further on. I don't remember exactly where this is, but that's just a really, really small part of the whole thing. But I found it interesting to find these kind of layers, because I think those sand deposits we have here, and there are many, like we have this kind of a mountain range made of sand here, and officially they are glacial deposits, but I came to think that these are dunes, basically wind-made structures. That's why some of them have just sand, some of them have bigger pebbles, and some of them are bigger stones. So like they got separated also mechanically due to the frequency of the winds and the strongness of the winds and all this kind of stuff. So
Whoa.
that's a little nugget for everyone.
Wow.
What is
Put
this?
here to this side.
Looks like Gizmo.
Somewhere in the Middle
It
East.
does.
Maybe, and hopefully I will find that again one day. Until that, good luck finding this. I have spent several hours this year already with finding this again. But I don't know. It's somewhere in the Middle East.
I'll do a
And-
Google Lens search and find it.
Okay, yeah, because that's a very interesting thing. There's like, not only do we have two craters side by side, but there seems to be some things going on here, and like that's that's a very interesting picture. And since I don't know where it is, I just thought I threw it out here. Maybe someone else finds it for me, so I can stop searching.
How do the mainstreamers even? How do they explain that? Like
Yeah,
these
volcanic
cyclones frozen in the rock, like it's wild.
They
Right.
just probably think it has to be some meteor crater or something like that. And maybe 2 weeks or so or something, I looked at the clouds once again, and I noticed this one here in the middle of the screen. And to me, I immediately recognized certain things. Now let's go on. This is maybe a bit too much for many, but that's what we are here. So here, this is something I figured out to make today, because in order for everybody to see, let's go back quickly. So that's the cloud. It rose up here. We have this feature here on the side, and you can see like the layer here, and also this feature here. In other words, this is rising up. Here we have this finger, let's call it finger, that is branching out to perpendicularity once again. And it's perpendicular to here, or maybe even perpendicular to here. And I think Michael Claridge explained in one of your talks recently, when he talked about current that produce the perpendicular field. Then we have the Hall currents and eddy currents, and the Hall currents. It's a fractal thing, so the perpendicular continues.
So you've got the
energy-
wire in the middle, and you've got the magnetic field that wraps around it perpendicularly, and those clouds that are circling the center column would be the magnetic field that wraps around.
Yeah, and they create magnetic fields, and they are electric currents. They induce the currents and stuff like that. So it's fractal. It continues, at least between the layers to a certain degree, layers of the atmosphere. So here we have the energy going up. We have this little feature here, and it's impacting. It's impacting the layer, the atmospheric layer that we cannot see. But here, like the animal cloud, it's the same principle. Here we can see basically the upper layer and this striation. Let's go back here. You can see here is one little feature, here's another one, and that's the outer line. So I just marked them here.
No, that's good.
But that thing was the thing that struck me. Okay, we have the energy going up, smashes into this surface. Yeah, I got once a little shitstorm done in the, what is it, Scholar? What is this one, the sun guy? This,
Sky Scholar?
Like he has beautiful Sky Scholar. Yeah,
Sky Scholar. Yeah, Pierre
yeah,
Robitaille.
I once asked in the comments section after a video, do you consider double layers as surfaces? And people were freaking out. It was very interesting. So now to me, like, double layers are in a way surfaces. Okay, so the energy goes up, smashes into the surface of that double layer at the atmosphere. It gets only visible as the air gets ionized and we see the clouds. And then we had this feature that goes out, and maybe we have also little perpendicular things. So this
almost
is,
like a
in a way,
electromagnetic fringe effect.
That's the impact crater of this plasma stream coming from here. The energy, which we can see here, fortunately, because the air got ionized, it formed a cloud that our plasma, it impacts. So this is basically an impact crater made of plasma.
Wow.
And you have this feature. So that's the yellow stuff, or orange, that's the impact crater. And that's
an
the
impact
blowtorch.
crater in the sky.
Yeah, that's the blowtorch. Andrew Hall, the arc blasts Earth. This is from the Middle East somewhere. That's where the impact crater, where the plasma torch hit the Earth, which is the same thing here.
There it is.
Oh, look at
The
that.
vortex. Then it impacted here, and here we have the Prandtl expansion fan, which is the same exact thing here. So this crater surface here would be our atmospheric layer on which this stream impacts. It forms the crater, which is this thing here, and we have the Prandtl expansion fan. And if you zoom in, you can see these perpendicular features, which are here
right there.
present.
Yeah, that's what I call the fringe effect.
Yeah.
Yes.
So this cloud is basically the same thing. Now we are back to what Andrew Hall once said: studying geology is studying petrified weather. But this time I made it the other way around. I just looked at the cloud in the sky and I thought, yeah, check it out, Andy. I found the expansion fan.
Right.
Well, a photo is also petrified weather. In a way.
yeah. That's material, it's the dust particle.
Yeah, and every shell of a capacitor, every plasma sheath contains its own kind of processes.
Yeah.
Like when we look at the solar system from top down, the places where we find matter concentrates in laboratory plasmas is where we find the planets forming around the sun. Yeah.
So backyard geology. So this is one of the little greenstone I have somewhere. Tonight.
Whoa.
And yeah. Let's move this somewhere else.
Oh.
There is this white
that?
stuff. I found it somewhere. I stumbled across it.
I just found it.
Yeah.
Holy crap. I've seen a lot of rock samples.
Fast.
I've never seen anything like that.
Yeah,
Robert Hawthorne would be interested in this, probably.
He'd be licking it right now.
He is licking it right now.
probably licking his monitor.
Yeah, it's very alkaline. Serpentinite. It's maybe asbestos. And with this, other things, this white reddish, these might be corroded magnetites. Greetings from Mars. Sometime I found this and I thought that, I don't know, should I bring this home? Does it fit into my pocket? So now let's smash it open. And I thought, dude.
Oh, wow.
I have to take it home because I really didn't expect this. Yet the outer side already seemed to be very interesting. Not the shape itself, but just the structure.
Oh, wait, go
And
back to
after-
it. Wait, go back to it. I was counting the layers. Okay, 1, 2, 3, 4, 5, 6. I can count 7 distinct layers. Thank you. 7.
I think you get more on the other side.
Yeah,
And for
I
some
only counted the
reason-
one on the right side.
I tried to polish. Now I have to try to get this again somewhere else. Let's put it here. Yeah, this material in the center, obviously it's somewhat brighter, and we have the layers. And I compared it to some Mars meteorite, and if you just look at the surface between a real Mars meteorite and the thing I found,
That's really close. That looks really close.
Quite
yeah,
close,
it does. Yeah, and also like when they cut open the Mars meteorite, you can see there is a certain layering going on in the Mars meteorite as well. Maybe not as well as in this example, but there is also some layer, and we have this black stuff. So maybe that's a
Black
Mars
stuff.
meteorite. I don't know. Would be interesting, or it would be very cool to know one day. Maybe one day I can bring it somewhere. And as we were speaking about Mars, now this is about like when I thought that, yeah, Steve Smith, you were talking about Mars. I had this already in my presentation. This is
Wow.
Europe. These are the Alps. So this is upside down. South is here to the top, north is to the other side, and maybe that's the mirror image of the Valles Marineris. I don't remember exactly. But if you follow from this dot to this dot, and I try to make it as clear as possible with the colors, you will find somewhere or somehow similar features on similar places within the Valles Marineris and Europe. I don't know. Maybe that's just a coincidence. Maybe it's not. Maybe I'm suffering from pareidolia. But anyway, there are
You
many
do see
points
repeating features.
there are like many.
Mm-hmm.
And the thing is, if you would zoom in, for example, this area, which is
That's what I'm doing that right
Romania,
now.
maybe, or something, you can probably find similar features as you can see here, because it would be very cool to have a similar map from Central Europe as we have from Valles Marineris, with the shaded areas like of the heights and stuff like this. This is the bathymetric map or something. Probably it would be a better fit even after this. I just brought this up. And now we get to the clouds. Yeah. There has been some white and violet display some time ago, and obviously it's not the sharpest picture, but the colors are very interesting.
Colors are beautiful.
So I even have a very short time lapse of these clouds here,
Oh, wow.
but I have made a field trip and I tried to film the whole trip in one shot, so the battery was very low as I was pedaling home and noticed these clouds. I wasn't in the best position in order to observe them, but
That's a great
I
picture.
saw them. And
Yeah, I've never seen clouds like that.
So,
the thing is,
Whoa.
this is
wow.
Holy
Wow.
moly. Yeah,
Wow.
it doesn't get
And
much more clearly a filament than that.
and the thing is, like, you can really see like the place where the cloud basically went up and down, they basically stayed in place. It was like the atmosphere was rolling over something.
Yes.
And in the previous picture, you saw like there were many in a row. They had the same height, the same distance. So I don't know if you are familiar with Dutchsins, the earthquake forecasting dude.
I'm
Nope.
not. No.
And he is talking about when there's like earthquake, like you have a 6-pointer somewhere and you have a 6-pointer somewhere, like, and you would just draw rings, and where the rings overlap, you get the next quake because there's a standing wave traveling through the earth.
No, I didn't know. I'm sorry. Who is this?
Dutch Sins.
Dutch
YouTube channel
Sins.
Dutch Sins. He is an interesting guy. I agree with some of the things, not all of them, but I like to watch his videos. He's very entertaining. He finds stuff.
Oh, it's
One N and put an E at the end, and it's one word. Sinze. Dutch Sinze.
That picture is blowing my mind.
Yeah, it is. Okay, Matt, we'll have to look that up.
Sinze. The E is at the end. I will send you a link to his videos.
Oh, yeah, dude, just do that.
Andrew Hall showed in his last presentation one of these clouds. I had them already also in my presentation, so this is a repetitive pattern. It would be cool if I would have a third one of 3 waves in a row, but I only have 2. So we
That's
have to
still
go with
really
this.
cool.
Now my
I see
mouse
clouds
is
like that
like
quite
that.
often.
Let's talk about dragons. In my first presentation I made here, I showed this one picture and I told you that I have other pictures of dragons or clouds that seem to represent or look like dragons.
Oh,
So we have
Yeah.
Andrew Hall, me here, that's the picture, and that's another picture. And here we have the snort, the eye,
out. Yeah.
the eye, bump, the bump. And he have a beard yet, or maybe that's a small beard. So they are not the same, but they are close enough. And somehow I came to think recently that the dragon is a plasma pattern itself.
Yes, I completely agree. 100%
Yes.
completely agree.
Now we have 2 pictures. Yeah, they happen to go into the same direction, which is maybe a coincidence. That's another one, even a colored one. This is also moving from right to left, the snort, the eye, the beard. And here we have
Colors,
the
wow.
little buckles. Yeah, it was a colorful high above. And you can see also the difference, like the clouds on the top of on the back of the dragon are different than on the lower side.
Mm-hmm.
Right.
And I'm still trying to figure out what's the thing. Like, there's like this double helix thing going through the sky. As we just learned.
It would be interesting to see the bigger, wider view and see what the clouds around it are doing.
Yeah, very often there are not really clouds around them. They are just those. That's they're all themselves very often.
Can I interject here? Could
Yeah.
it be there fluffy on one side and sleek on the bottom because
Yes.
they are on opposite sides of a double layer? Like right on the cusp of a double layer. So
Yeah.
on one
I
side
have
of the
to-
double layer, you're getting the sleek clouds, and then on the other side of it, you're getting the fluffy ones.
Yes. Yes.
So
This
it
is
could
something
be,
like it might propagate at the boundary of the double layers, which is probably part of the reason the whole thing exists.
Right.
I agree.
So, and the thing
that
is
would-
also like if we have a double layer, and now at the picture we are looking at, we basically see it like this. But if
Yeah.
you see it like this, you only see one.
Right.
So we have to wait until the double helix exposes its both helixes and at only one. If you just see only one, you probably couldn't figure out if it's rotating or if it's a double helix. But when it turns like this, you can see both. So it's also a thing of perspective,
Exactly.
yeah,
Is it-
time.
Is it smooth because as it's approaching the underside of the double layer, it's being accelerated, and then once it crosses over, it just kind of drifts off of it, and that's why you get the fluffiness on the other side?
No.
Because as I
Almost-
understand,
almost
charged
certainly.
particles accelerate toward the layer, and the ones that are fast enough cross over.
Yeah, and one thing is also I have some pictures and maybe even videos about where you can see there are 2 clouds side by side, basically, and you can see from one cloud there is like rain falling down. You can see it in the sky. There's this dark shadow below, and if you look a little bit to the left, you can see another cloud where it rains upwards. So you can see the same pattern on both ways, but one is upside down. So, like, it's
I want
very
to see
interesting.
that.
But
I have to search for that.
about
But the thing
rain,
is, yeah,
So-
like to me, like in nature, very rarely things get pushed. Generally, they are pulled towards something. They are not pushed because the movement is very often generated by attraction.
yeah,
So things get pulled. In other words, as the water gets pulled up to the heaven in order to form clouds, to some degree, which is not the whole story, it can get pulled down as well. So when it's raining, the water gets pulled from the atmosphere back down to the. It doesn't really fall because
It gets
probably
pulled.
you have experienced
Right.
it. Rain hard, really hard, very big drops fall really fast, and sometimes they don't really drop at all. On a foggy day, they're just suspended in the air. So in that
well,
case,
what
really pulled towards Earth, they're just at perfect equilibrium. The air, you're just there standing in the foggy day.
But what happens to that vapor up there at the edge of the shell into the next plasma sheath up? What happens to it that turns it back into a drip and then it gets pulled back down toward the Earth? Why is it losing whatever makes it voluminous and float? I suppose.
I think it's in a way, we have the different atmospheric layers. We have outer influences from the sun that will penetrate through certain layers. And in every layer, they will react differently to the environment, the stuff that is there, and all these kind of things. It's also about, I think, in a way, the thickness or height of the layers and the energy which is coming in, its frequency. So how many times basically it can travel back and forth until it reaches the next double layer. So we have the length, the frequency, which is the length of the wave, the amplitude, which is the height of the wave.
Power,
so we have this perpendicular, which is going through the layers. So the layers are of different heights. So they will react just according to their frequency differently in the different heights. Furthermore, we have different electromagnetic potentials in different layers, different light conditions. So that's the thing. That's the spooky action over distance in the atmosphere on Earth. For example, you don't see any clouds beneath this one here. So there's just something going on here. And here in the background, you can see clouds very high up. And to me, it's very hard to imagine that these clouds that are floating, maybe some 15 kilometers in height, that they propagated from some lake all the way up there. No, there has been some dust up there. Energy went through, ionized the dust, and the water vapor, which is already there, just gets visible by the ionization of the,
Well, the sun is probably creating water molecules and spraying them all over the surface of our planet, isn't it? Isn't that how we get water vapor in the upper atmosphere?
Yeah.
Through the Liner process?
Yeah, probably part of it is also like due to what Earth is or what Earth is about. It's basically about water in a way. Mm-hmm. It's the water planet. So what else would you expect the atmospheric layers would exhibit the most?
Well, they say water can't evaporate up past a certain height in our atmosphere. I think it's like the ionosphere or something. But we do get clouds above that, which has kind of always been a mystery.
Yeah, the thing is, like, if you think about water, it's H2O. Yeah. Mm-hmm. And H is hydrogen, which is the most abundant element in the universe, as far as I know.
Mm-hmm.
That's what it said, yes.
Yeah. So, and also the thing is that there's like, as I earlier showed, that there's like stuff in the solar wind, like dust.
Right.
So some of the dust probably accumulates on the outer layers of Earth's atmosphere. So, and if there's dust like that got expanded in the layer and energy flowing through that layer, that dust gets ionized And this is maybe the crucial point where we get back to what plasma actually is. It is ionized matter. And this ionization process of the dust particles could probably produce this chemical reaction that forms water. And as the ionization process stops up there and the dust particles aren't ionized anymore, the water will just dissipate again. So, I don't know. It's really hard to
That's a good answer.
Explain that, but like the energy travels through space. Like light doesn't do anything until it hits something.
Right.
So like that's why maybe people think space is empty, but yeah, we cannot see like really much because we only have this very narrow visible light spectrum that we see. And all the other stuff is invisible to us, but there are many kinds of energies, frequencies, and amplitudes of the energy itself, and many different kinds of environments, not only around planetary bodies, but between planetary bodies or galaxies and stuff. It's not a void. And it's like everything is in move all the time. So
the more that I've really been studying and doubling down on trying to understand plasmas. And just for those that don't know, plasma has 3 states. It has arc mode, just as the sun and lightning. It has glow mode, which are the auroras behind Stefan there. And it has dark mode. And dark mode is apparently everything around us that we see. And Stefan, last year in the salon presentation, you said the phrase, clouds are plasma. Now, that doesn't fit the standard definition of what plasma is, but I'm going to have to agree with you because clouds, and what we've been talking about for the last 5 minutes are that the clouds sitting on layers. Well, these aren't temperature layers because the temperature, I mean, they can be. This is very, very complex, but they have to be charged layers that the clouds are sitting on. If they're charged layers, that means that the clouds themselves have to be charged, which is the definition of plasma, that it's charged gas. It's charged.
The cloud nuclei. It's static. It's the static electricity of the cloud nuclei that attracts the water molecule. Dude. Yeah.
Exactly. So when you say clouds are plasma, I'm right with you. And if people want to see the complexity of plasma, look up. Look at the clouds.
Yeah, look at petroglyphs and see if you find similar patterns in the sky in your backyard. So that's the same picture, and that's the rotating area. You can see the bow, like in a way it's coming from here, and it's rotating. Yet another dragon.
Oh, look at that. Beautiful.
Lord, maybe the eye here, and like the beard, and all these kind of things. So it seems to be a repetitive pattern.
Yeah, it does.
So we know we are basically almost at the end of this little presentation. After that, we can talk about whatever you want.
Wonderful. Thank you.
We know about the history of the peer-reviewed process, how it has been, or it has been tied to Christianity in order to make sure that no one tells anything that could reveal that the king doesn't have any clothes. Okay.
Naked
emperor. So this is the picture. This is the picture I was like. It's behind me at the moment, but the lightning and everything. It has been behind me, and it's my last presentation. But I just didn't have the guts to tell really what I think. So now I have the guts to tell what I think.
Hooray!
Oh, yeah, let's hear it.
Hooray!
See where it goes. So this guy here in the back, that's Lalli, and as you can see, he has this axe. And this picture is an official, it's rather big. It's maybe almost a square meter in size. And I bought it in a secondhand store. And this has been hanging in Finnish classrooms probably for decades.
Really?
And it's an official classroom picture, basically. But nowadays, no one really talks about this, and I doubt that this is hanging in any classroom anywhere. So the thing is, Lalli, he wasn't like how to say, a good man or something, or a hero or whatever. He was just like some random dude. But this priest was the first Christian that came to Finland and tried to spread Christianity. And he took food and stuff from Lalli's home without permission. He was paying for that. He gave the people something, but he just took without permission food and stuff and left. So Lalli catched up with him and ended him. So that's the famous story how a pagan was hunting down a Christian.
Don't touch my stuff.
Yeah, that's
Spear or the axe.
Nowadays, we are living in a science world that is ruled by peer review and all those gatekeepers and stuff. And that's why I think it's time for a new Lalli 2.0. Because modern science rather often thinks that, the old people, the pagans, they didn't know anything. But now we know everything because we agreed in 1960 that relativation, gravity, and all this, whatever. So, but if we would
Speed
get
of light
rid
is
of
fixed.
that, so
Magical unicorn explosions.
Stefan Amala calling for revolution. Scientific revolution with an axe and a spear.
Yeah. And like what I said earlier about like being a magician or witch or whatever, like it's those peer-reviewed papers. So I made science. So I also proved that you don't need to be a scientist in order to get some science done.
Correct.
So what else? That's some picture some time ago, the right-hand rule. Generally accepted assumptions are often majorly wrong. Those who have the eyes to see, the heart to feel, an open mind, and the courage to think know that we are all right. You know, we are electric universe people are all right because we are all right. Like Gada explained, out the right and left hemisphere.
I got
it. To the left, you can see that's a mechanical thing. There is a pipe where we have hot exhaust. And you can see those structures beside the pipe, and they are exactly arranged like the right-hand rule because the energy goes that way. Every day, like if I try to explain the right-hand rule to people, they look at me like, what are you talking? You cannot explain like this. But if you cannot explain stuff simply, it might be wrong. And in order to prove the right-hand rule correct, you can use thermohydrodynamics, for example. Yeah, it's just an exhaust, but someone who planned or like whatever had to do with this exhaust probably knew about the right-hand rule. Because I haven't observed any of those exhaust pipes that would have these kind of similar features that would go the other way around.
Yeah.
Wow.
If someone sees one of them that has these kind of features, but they go to the other direction, please send me a picture. I would be very interested.
I've never seen an exhaust pipe with any kind of swirlies going up it before.
Well,
yeah, they're just, I think they're helping to create the vortex.
This is Victor Schauberger's work.
Yeah, basically.
This is Victor Schauberger.
Yeah.
Absolutely.
Basic
Stefan, well done.
Thank you very much.
Nicely done. So,
very cool.
So
Any
cool.
questions? Any questions?
I think what's going to happen, I don't know if I have any questions. I've taken massive notes. I don't know if you can see my screen right here is full of Post-it notes of stuff that we're going to look up. I've probably got almost 10 different notes that we're going to look up. And then when this video posts, watch the comment section because I think you're going to get a lot of questions. And make sure and go on.
Yeah, I'm very interested. Yeah. Yeah, it's very. Yeah. That's one of the reasons why I brought some like rather thought-provoking things here.
Indeed.
Are you willing to go quickly to the deep end of the rabbit hole?
Always.
Let's go. Go for it. Bring us down there.
It might not be it might not be fun, but I think it's still very important because, yeah, it's maybe something many of us still have to deal with. So,
Let's hear it. What do you
how to
got?
apply certain, it's about transmutation of the elements, it's about feelings, about stuff like this. So, a few years back, my father died. And since he was living in Switzerland and I was living in Finland, it was a rather distant process, which didn't make it any easier.
Yeah.
So it was about a day or two after I got the message that he passed away. I stumbled across an article that was making research about brain activity at the moment of death. And it turned out at the moment of death, there's a huge spike of electricity in a human's brain. And I thought that not only it's very interesting that this thing came to me in such a moment, but I also realized that, okay, when you think about a huge spike in electricity, you might think about a spark, lightning, a light. So I have been thinking about this, and I came to the conclusion that it seems that scientists have proven that there is a light for everyone at the end, because there's a huge spike of electricity at the moment of your death. That's the light at the end of the tunnel. Okay.
Wow, that's
a little bit later, my mother died. And I happened to be in a hospital at the same day in another country. And we were in an elevator, and I had a flashback to my childhood. And I saw pictures. Like, I suffered, had several near-death experiences, so I know how it feels when you see the film of your life. It wasn't the first time, but it was different. And it happened to me about 3 times or something. And later on that day, I got the message that she passed away. So it was very strange to have this kind of flashbacks. And there was just like pictures, some like video clips, but no sound. A day later or two, I stumbled across an article. How comes? That was talking about different frequencies of human brains. And it turned out that human brains, the gamma band frequency, is related to the vision.
To the what?
To the vision of our vision system in our brains, like the eyes.
Vision?
Vision. Yeah, vision.
Okay.
So I thought, yeah, that's amazing. Not only do we experience the light at the end of the tunnel, but also what Rupert Sheldrake, and Rupert knows about my experience. We had some little talk about this. I sent him a video I made, and we were talking about morphic resonance and stuff like this. So maybe this is a little bit private or whatever, but it seems to be. This is how serious basically I am with these things, because you can really take something away with this. That I think they were trying to reanimate her, and every time before they had to reanimate, I got the transmission, because the electric spike in the brain of a dying human compared with the gamma ray emission spectrum that is related to vision, combined with the morphic resonance. Yeah, so we have the electric spike, gamma ray, which is tied to the vision, and Rupert Sheldrake's morphic resonance.
How far away were you from your mom?
We are connected about 2,000 kilometers. But it doesn't matter the distance, because
the distance apparently doesn't matter.
Yeah, after all, when you think about this, think about one saying. Something came to my mind. Yeah. in order for something to come to your mind, it needs to have to be somewhere else before.
Right.
Somewhere, the energy, which is the information, is stored and it comes to you. And they're like, in German or Finnish language, it's the same thing. Something comes to your mind. Then we are back to what I said in my previous presentation about the open minds and closed minds. If you have a closed mind, there's nothing that can come to your mind. But if you have an open mind, there are many things that can come to your mind. So that's, for me, it was very amazing in a way to experience these things. I made videos about this. I've been thinking about, and it was very amazing how understanding of the mechanics helped me to cope with the emotional reactions and stuff. And for example, about the transmutation of the elements and how it could be possibly be an analogy of how Earth is functioning in our solar system. If you get a message from someone, 3 words are sufficient enough in order to trigger in you some chemical reaction, which we are calling feelings. And let's say it is a rather sad message that you receive, and the energy confined within this message is sufficient enough. It can trigger in you such a reaction that your body needs to discharge, and you probably cry. And it's also helpful to understand that it depends on what or why someone is crying, because the tears are made of different things. If you're crying because of happiness, physical pain, mental pain, anger, or whatever, the tears are things. So you get a message, very sad, you feel bad, you cry. So the information, that is the energy that gets probably transmitted to you by light when you're watching your phone, goes into you, your body reacts, and you cry, you produce matter. That's why certain things matter and certain things don't matter. If it doesn't trigger an emotion in you, it doesn't matter too much. But if it triggers an emotion in you, it matters, because you could measure the blood content, adrenaline, dopamine, or whatever you have. Yeah, there's a difference after you get the input of information, energy. So Earth receives energy from the sun all the time. It goes into Earth, it transmutes into actual matter, and it will pour out of Earth in some form, maybe lava or whatever. But it's basically the same principle as a human receiving a message. There's a reaction, more energy input. Every information is energy. It just depends on the polarity. It's plus or minus. So it will trigger a chemical, physical reaction, and you get material, matter. Things matter or don't.
Theory of everything.
This is how I see the analogy between how humans work when they receive information. We have an aura, the same as Earth. Earth receives energy. It's materializing and it comes off, and after a while, the whole thing starts again. So that's a small dive onto the deeper end of the rabbit hole. How you can apply some certain understanding and knowledge into real life, and hopefully, this little talk about this, might be not too happy theme, hopefully helps at least one that has seen this once when he comes to be in such a situation where he has to deal with.
Can I add a little something to this, Stefan? I just saw a presentation from the IONS laboratory, IONS, in California. This is the one that Dean Radin is in charge of. And since I follow them, they send me notifications of presentations that they do. They just did one with Dr. Garrett Yount, where he talks about something called the heart toroid. The heart toroid
Yeah.
is exactly what it sounds like. It is an electromagnetic energy field in the shape of a toroid, which we all know. That's the donut shape that we all know. It extends about 3 feet in front of us, and it is centered on the heart. The heart actually, they're
Yeah, it's a
thinking the
war.
heart actually generates it. But
Yeah, it.
so they finally were able to measure that with something called a squid magnetometer. It's this fantastic, amazing piece of equipment that measured this magnetic field. But Stefan, they are studying, the Heart Math Institute is what's studying this. They have
Yeah, I
found that
know.
the heart toroid actually communicates not just with the body's cells, but it sends signals from the heart to the brain. Now, we're always
Yeah,
taught that it's the brain sending signals to the heart that makes it go. And they're saying, no, it's kind of the reverse. The heart sends signals to the brain.
yeah.
I mean, the brain does send signals to the heart, but nobody knew that there was that direction here. The other thing
Feedback loop.
Yeah,
is that if it's a toroid, if it's an energetic toroid, there is light associated with it. It is a frequency of light.
yeah,
So a lot of people,
yeah.
I made a video on this, and a lot of people put it down like, oh, this is your consciousness. Oh, this is your aura. Yeah, probably. But the last thing is that he talked about, the Heart Math Institute talked about how this heart toroid communicates outside of the body. It doesn't just communicate with cells inside your body, it communicates with other people.
Yeah, yeah,
Other people,
yeah.
Stefan.
Yeah, like, I'm trying to remember the name of this one guy he was talking about. Bruce Laybourne brought this to my attention. Greetings to Bruce. Very cool guy. Anyway,
Yes.
about the heart being a vortex generator. And the
Oh,
thing is, like
yeah.
if you think about, like, your heart is about the size of your fist. And our veins and all, like, those little veins we have in our body are about 100,000 kilometers. So, like, show me one machine, a pump that is the size of a fist that can pump such not really liquid fluid as our blood through a body without producing hundreds of psi of pressure. So, like,
Yeah.
if the heart would be a pump, we would be pressured up, and if you would cut your finger, it just would go boom.
Yeah,
But we
exactly.
don't. Okay?
like a Chinese kung fu movie.
Yeah, yeah. So not only is it impossible to build such a small pump in order to pump such a thick fluid through such small veins without creating the pressure needed, but it's also like we would probably need a huge energy supply if it would be a pump, like, a battery on our back.
Yeah.
And the thing is also, Michael Faraday, probably you have heard of him. He made some research about the heart, about the blood and stuff, and he figured that the blood, as it reaches the point where it goes back, it changes the polarity. So, as I said before, rare things in nature are pushed, they are pulled. So I think the heart gets pulled towards the outside, and the skin, or maybe the fascia, or some of those layers, forms or is basically a physical double layer. Maybe it could be also outside of the skin.
Yes, I was going to say it could be the fair weather field that it's attracted to, maybe, which is outside of our bodies. That's everywhere.
Yeah, so the heart it gets pulled towards the outside, and as it reaches the farthest point, it just switches the polarity and it gets pulled backwards in. So
that's a really interesting idea. Dr. Gerald Pollack has talked about how that the easy water that is inside our bodies is actually the battery that might actually help be responsible for helping the blood circulate. But let's add to that idea that it might be pulled and then pulled back and then pulled back. That's a great idea. Let's investigate that.
So how does a pump work? A pump pushes the water through a pipe. So there is like a minimal pressure. Like, I don't know how much pressure you have just where the blood comes out of the heart, but it won't be many psi's. So there's a minimal pressure. there has to be a certain amount of pressure because we have gravity and stuff.
Right.
So, but on the other hand, like if you think further, there is not really pressure. So if a pump's fundamental principle is to push the water through something, then the heart cannot be a pump because it doesn't really push anything.
No, it's more like a bullet train, magnetically suspended in your veins.
Yeah, like
where your blood is one polarity, your artery walls are another polarity, and it's accelerating your blood right through the veins.
Yeah. Like Eric Lightwhite's magnetic river, in a way. Something.
Google
magnetic rail gun.
Right. I just did a quick search on Google. Google doesn't have, or the Google AI doesn't have an answer to what the PSI that the heart puts out.
Blood pressure in the human circulatory system is measured in millimeters of mercury, not psi. A typical healthy reading is 120/80, which is about 2.3 psi when the heart pumps and about 1.5 psi when it rests. Pressure is highest in the arteries and much lower in the veins.
Which is
probably
kind of stupid because if we didn't have any idea, then blood pressure wouldn't be a thing. We wouldn't be able to measure it. We wouldn't be able to take medicine for it. Blah blah blah. So, Google AI.
We need a certain kind of pressure within ourselves in order to be ourselves, in order to maintain our stature and stuff. Okay, like if we would be like a shark. Like the main difference between whales and sharks is whales, they have a skeleton.
Right.
And sharks, they only have the
cartilage.
Yeah. So if you pull a shark onto land, he will die sooner or later because he gets squeezed by gravity and he cannot breathe anymore.
Well, they always have to be in motion.
So, yeah, in order to get the oxygen filtered through their bodies. Right. But the thing is, like, there has to be a certain amount of pressure, like in plants or something that are rather static beings. They have also the skeleton, in a way, like the leaves, and only between the layers, there's the stuff flowing. So they have also something that keeps them in shape. So
right. Well, again, going back to Dr. Pollack, he was saying that the easy water layer inside plants, another thing, acts like a skeleton. It produces a force that allows plants to punch through concrete, punch through asphalt. Because you're right, it has to take a huge amount of energy. Where does that energy come from? Easy layer, the easy layer water, which for all intents and purposes, kind of going full circle, Hale, it looks like it's a double layer. It has the same properties.
Yep.
Yeah.
Theory of everything.
Stefan, we're going to wrap this up, but holy crap, this has been awesome. This has been so great to talk with you again. I know it's been a few months since you and I have chatted, and I'm glad we were finally able to bring Matt in on this.
Yeah, it's fascinating.
Thank you very much for this possibility.
So
that's very
Thanks,
cool.
Stephen.
Yes, I've been waiting for it.
Take care, man. We'll see you. Bye-bye.
Thank you. Bye-bye.
Thanks for listening to the Brainstorm with Sparks and Finn. Hope you learned something new or found some food for thought. If you did, take a second to smash that like and subscribe button and consider joining our Patreon to help Sparks and I spread the word. And then join us next time as we explore this amazing electric universe. Cheers!